Okay, in this problem we have A of X represents the number in hundreds of computers sold when X $1,000 is spent on advertising. So we want to represent the following statement by the equations involving A and A prime. Okay, when $11,000 are spent on advertising, the number of computers sold was 1,200. So that means A is in, it says X $1,000. So if $11,000 is being spent, that means A of 11 equals, let's see, it says how many? 1,200 computers were sold. A gives the number in hundreds of computers sold. So A of 11 would be 12. So it's not those. And it was rising at a rate of 50 computers for each $1,000 spent on advertising. A derivative is a rate of change. It tells you the rate at which a quantity is changing. So that tells you that when $11,000 is spent, so the derivative of A at 11, the rate at which A is changing is rising at 50 computers. So it's going to be positive because it's rising. And since computers is in hundreds, this would be a half, positive a half. This should be part A over there. Then we'll look at B. So estimate the number of computers that will be sold if $13,000 is spent on advertising. Well, we're currently only spending $11,000, so that means we need to increase A by 2. Okay, we know it's rising at this rate, so this also, in terms of marginals, tells us the approximate amount that A would rise if X increases by 1. So this tells us that A of 12 is approximately equal to A of 11 plus A prime of 11. That's what marginal cost means. And we can take it one further and say A of 13 is approximately A of 11 plus 2 times A prime of 11. So A of 13, number of computers sold, if 13,000 is spent, would be A of 11 is 12 plus 2 times 0.5. So 2 times 0.5 is 1, so 13, and the units are in hundreds of computers. And it does not actually say the word hundreds, so we would need to enter 1,300.